So section 6.3, the first thing that we're going to deal with is we're going to deal with operations. Now, operations are relatively simple, but now we're dealing with polynomial type functions. So we have four basic operations that we are going to be doing. We are going to be using addition. We are going to be using subtraction. We are going to be multiplying. Actually, we'll call it multiplication. Restart. I don't know how to spell. And we are going to use division. Now, the basic rules of addition, subtraction, multiplication, and division, rules that you've been working with for over a decade, still hold. Okay? Don't be scared by the actual what the function looks like. Okay? Your basic rules still hold. If you're going to add something, they have to be like terms. If you're going to subtract something, they have to be like terms. If you're going to multiply two things, you can multiply whatever you want. Okay? If you're going to divide two things, we might have to simplify some things. Okay? If we're dealing with fractions, okay? If we're dealing with adding and subtracting fractions, because we can have rational or polynomial fractions. Okay? If we're dealing with that, if we're adding them or subtracting them, we got to have a common denominator. All those things, all of the things that we're dealing with radicals, things that you've been doing for the better part of a decade or more, still hold in this stuff. Okay? So, I have f of x there, and I have g of x there, and from that, we are going to be adding those two. Okay? Then, what we need to do is we need to rewrite them. So f of x here would be 3 times the fourth root of 2x plus 8 times the fourth root of 2x. Now, the question that I have is, are those like terms? Yeah? Okay. They're both fourth roots of 2x. So if I have 3 of them and you give me 8 more, how many of them do we have? 11. So this is 11 times the fourth root of 2x. Again with subtraction. So this would be 3 times the fourth root of 2x minus 8 times the fourth root of 2x. Are they still like terms? Yes, they're still like terms, so I can subtract them. 3 minus 8 gives me negative 5 times the fourth root of 2x. Okay. I can multiply them. 3 times the fourth root of 2x times 8 times the fourth root of 2x would be like 3 times 8 times the fourth root of 2x squared. Correct? 3 times 8 is 24. So this is 24 times 2x to the 1/4 power squared. Power to a power, what do? We what? We multiply them. So this is really 24. Actually, here, we'll write it like this. This is really 24 times 2x to the 1/2 power, or 24 times the square root of 2x. Rules of exponents, unfortunately, never go away. Dividing them, what happens to the 4th root of 2x? It cancels each other out because there's one on top and there's one on the bottom. So this is simply just 3/8. Okay? You go now and try with those two functions. So this is x to the 4th plus 5 over x. Can I add those two as is? No. So what do I have to do? Common denominator first. What is my common denominator? 4x. So then this one becomes x squared. This one becomes 20. So this here would be x squared plus 20 over 4x. I would accept either or there. Move those around for a little bit, give myself a little extra space here. Here then, this would be x over 4 minus 5 over x, which then the only thing that changes in this whole methodology here is the addition sign to a subtraction sign. So then this would be x squared minus 20 over 4x there. Okay. Multiplication. So it would be x over 4 times 5 over x. How do I multiply fractions? Just straight across. Yep. So I can either simplify first or simplify last, but either way, I get 5 over 4 there for that answer. Division. X over 4 divided by 5 over x becomes x over 4 times x over 5. Flip, reciprocate, if you will, the second fraction or the bottom fraction, and then this gives me x squared here over 20. Questions on that? Next topic that we need to talk about is the domain of a function. The domain of a function is all of the number values that I can put into the function and still have it produce an answer or produce something out, give me an output. Okay? It's the inputs, if you will. Now, 9 times out of 10, that input is the x values. Okay? We might have a function every once in a while that might be like a height function based off of time. Okay? So then our input would be time, h of t. Okay? But most of the time, our input values are going to be the x values. Okay? Now, in a majority of cases, the domain of a function is all real numbers. Okay? Now, if you are a writer and you want to write out all real numbers every single time, more power to you. Okay? Write out all real numbers. Okay? If you want to use the shorthand of it, the funky R, okay, then use the funky R. Okay? That's the symbol for all real numbers. Okay? The double-sided R. Okay? There are only 2 cases in which a function will not have a domain of all real numbers. Okay? The first case is if we have a fraction with a variable in the denominator. Okay? A regular old fraction would still have all real numbers as its domain. The thing is, the variable has to be in the denominator. Okay? And if we're in that case where we have the variable in the denominator, we have to make sure that the denominator is not equal to 0. Because we can't divide by 0. So that's our kicker. Denominator can't be 0. The second thing that we have to watch out for is when we have an even indexed radical. Side note, remember that the index on a radical is right there. Okay? And that a square root has an index of 2. We just don't write it. Okay? So the index is there. If we are dealing with an even indexed radical, then are inside the guts, if you will, of the radical has to be greater than or equal to 0. Because if it's not, then we go to imaginary land, and our answers become imaginary. We're not dealing with imaginary numbers in the domain. We're only looking for real numbers. Okay? So those are the two things that you're going to ask yourself every single time. Does it have a fraction with a variable in the basement? Does it have an even index radical? If the answer is no to both of those, your domain is all real numbers. If your answer is yes to one of them, then you've got to either set the denominator equal to 0 and solve for it, and that becomes a restriction in your domain, or you've got to set the inside of the radical, the radicand, if you will. You have to set the radicand greater than or equal to 0 and solve for it, and that gives you restrictions. Okay? Let's put that to work. So I've got three functions here, a, b, and c, all of x. Okay? First question you ask yourself, in function a, is there a fraction with a with a variable in the basement? No, not even a fraction. Okay? Second question you have to ask yourself, is there a radical that has an even index? No, not in this case. So the answer was no to both of those cases. So the domain here of A is all real numbers. Function B. Do I have a fraction with a variable in the basement? Yes. Do I have a radical? No. So because I have a fraction with a variable in the basement, I say to myself, x minus 2 cannot be 0. So x cannot be positive 2. With me? So the domain here of B is all real numbers with the exception of x cannot be equal to 2. Function C. Do I have a fraction? No. Do I have a radical? Is it an even index radical? Yes. So the insides has to be greater than or equal to 0. So x here has to be greater than or equal to 0. So the domain here of my function then is all real numbers with the exception x has to be greater than or equal to 0.
So index radical 0 is even?
That has an index of 2. Because it's a square root. From what I had said earlier, we just don't write the 2 there. Yeah. Okay. So, domains now on operations. Okay? When you perform an operation with 2 or more functions, you need to be aware of the restrictions that apply to each function and the resulting function after we did the operation. Okay? There's a lot to think about here, so you might need to stop and think. Okay? So, going back to m and n are two functions that we had before. Okay? We added m plus n, correct? Okay? And we got x squared plus 20 all over 4x, right? Okay? So in order to find the domain here of all of this operation, I first have to look at the domain of m of x. Okay? What is the domain of m? Do I have a fraction? Yes. Is the variable in the basement? No. Do I have a radical? No. So the domain then is all real numbers. Then I've got to look at the domain of n of x. Do I have a fraction? Yes. Radical in the basement? Yes. So x cannot be equal to 0. So this one is all real numbers, but x cannot be 0. With me? Then I look at the domain now of my operation. So now I'm looking at this function right here. All real numbers, with the exception x cannot be 0. Right? Okay. So I look at all of those and I put those all together. The domain of my new function is all real numbers, but I can't have 0 because that would make n not valid. I can't have 0 because that would make my operation not valid. But I don't have anything else. So that is the domain then of my new operation function. Okay?
Wait, so the last green, that one is the exact same always without limits?
No.
How do you get that last one?
This one?
Yeah,
I took the domain, I looked at just at this and here in the green box.
okay, so then what's the other one?
That's the domain when I put them all together. Here, let me show you a different one. Okay? So, when we took those two functions, we multiplied them, we got 5/4, right? Okay? So the domain of m was all real numbers, right? The domain of n was all real numbers with the exception of 0. Right? Now, the domain of my operation so now I'm looking at my green box again. What's the domain of that function? All real numbers. Okay? So the domain of my operation now then becomes all real numbers, except I've got this restriction here hanging out from n yet. So that restriction has to come into play. Because I couldn't get my operation function without getting all of n. So if I put 0 into n, it doesn't work. It kicks out an error message. So that still has a restriction then that carries on. That clean it up just a little bit more? Okay. Try those two.
this would be 3x plus 2 times 4x minus 7, which then would be here, that would be equal to 12x squared minus 21x plus 8 is minus 13x minus 14. There. Do I have any, so now then I've got to look at, so finding the domain here, I got to look at the domain of K. What's the domain of K? All real numbers. What's the domain of D? All real numbers. What's the domain of my operation? All real numbers. No restrictions, correct? So then the domain of this function is all real numbers. Because there was no restrictions to change anything through there. Okay. Here then, k of x was 3x plus 2. D of x was 4x minus 7. So there's my function. Nothing can simplify out of any of that. So my domain here of k of x was all real numbers. My domain here of d of x was all real numbers. And what's the domain now? Oops, it should be capital D's, not lowercase d's. And the domain of my operation is what? No, x can equal 0. So I do a little sidebar action. 4x minus 7 cannot be 0. 4x cannot be 7. X cannot be 7/4. So my domain here would be all real numbers, but x cannot be 7/4. So the domain of my function then is try those. Can't combine anything, so that's my new function. Okay. So the domain of f of x, all real numbers. The domain of g of x, all real numbers, but x has to be greater than or equal to 0, correct? Okay. And then the domain after my operation mirrors that one. So the domain here then would be all real numbers, but x is greater than or equal to 0. Okay. So there's my function. Nothing can be simplified. Domain again of f of x is all real numbers. The domain again of g of x is all real numbers, but x is greater than or equal to 0. The domain here now after my operation what changes in my domain of after my operation? Or does anything not change? It's all real numbers, right? Do I have a fraction in after my operation? Yes. Does that fraction have a variable in the numerator, or excuse me, the denominator? Yes. So the denominator can't be 0. So the square root of x cannot be 0, right? So that means then that x cannot be 0, correct? But what also is in that new function? There's a radical, right? So the second thing that I have to consider is the inside of that radical, which is just x, has to be greater than or equal to 0, right? So combining those two, because the radical is in the basement, combining those two, my x gets restricted to just greater than 0. I can't have x be equal to 0 anymore, because that would make my operation not valid. Again, there's a lot to think about because you've got the domains of two functions to start with, plus then now you've got a new function that you've got to deal with the domain, and then when you're giving the final restrictions, all of that has to come into play. Okay? Tomorrow, we'll move on to compositions of functions, and then finding the domains of compositions of functions, when there's even more to think about tomorrow. Oops. Gotta go all the way. There it is. Here's your homework. This homework will be due on Thursday. So what is Thursday? 17th? Because you can't do all of it yet. Okay? Yeah. You can start it tonight, but you can't get it all done tonight. You can try if you want. Compositions really aren't that